Welcome to the deep dive. Today, our mission is to break down the expert assessment for some really severe weather across Northern Eurasia from December 6th to the 15th.
Right.
And this isn't just a simple cold snap. What we're seeing is what forecasters are calling a profound atmospheric dichotomy.
Which is a technical way of saying the continent is literally being split in two. You have two major and very different hazard zones running at the same time.
And this split isn't random.
Not at all. And that's the core insight for you. What's driving this is a powerful alignment of two huge climate forces. We have a weak La Nina event coupling with a really early, really major disruption of the polar vortex.
So that dual forcing is basically creating an atmospheric squeeze play.
Exactly. It's setting up these intense pressure gradients that are, pushing the western half into warmth and wind and the eastern half into extreme dangerous cold.
Okay, so let's unpack that. Let's start with the West. The immediate picture there is a screamingly positive North Atlantic oscillation, or NAO plus app, which in simple terms means a huge jet of wind and warm, moist air is just barreling right into Western Europe.
It's the perfect mechanism for extreme rainfall. We're tracking sequential, very intense cyclones. The first one, a precursor, Storm Bjorn, is forecast to hit 970 hectopascals.
And just for context, 970 is the kind of pressure you see in a strong Category 2 hurricane.
Right, so when you have other systems following that, overground that's already described as very soggy, the main risk is compound flooding.
And what does that mean for infrastructure? We're seeing forecasts of, 50 millimeters of rain over high ground in eastern Scotland?
Yeah, and that's falling fast onto already saturated ground. So the major risk there is what we call dynamic load failure.
Okay, so not weight, but force.
Exactly. Think of sudden violent force. It's high winds creating immense sideways or lateral stress, pushing transmission towers, tearing it to buildings. It's damage from movement.
That sets the scene perfectly for the other half of the story, the east. Because all that warm air surges west, it's basically shoving the Arctic air mass into place.
It is. The chain reaction is that the polar vortex disruption, it opens the door for a switch to a protracted negative phase, the NAOAO.
And that's the trigger.
That's the trigger. It unlocks that deep continental cold and allows it to pour west across Russia and into Eastern Europe. We're talking central Russia dropping to around -10 Celsius with blizzards, a really severe winter regime.
But the cold itself isn't the biggest threat, is it? The real catastrophe zone is along the boundary.
Precisely. The highest systemic hazard is that thermal boundary across Eastern Europe, think Ukraine, maybe the Balkans. That's where that frigid Siberian air crashes into the warm, moisture-packed Atlantic air.
Creating the perfect setup for
What?
Freezing rain.
Catastrophic freezing rain and icing events. And unlike the West, the infrastructure risk here shifts completely to static load failure.
So from wind to weight.
Oh, wait! The sheer devastating weight of accumulated ice. Imagine power lines and communication towers just collapsing under hundreds of pounds of solid glaze ice. That's how you get mass, long-lasting power outages.
So how is our changing climate playing into this?
Yeah.
Is it amplifying both sides of this split?
It's acting as a primary risk amplifier, yes, for both. A warmer atmosphere holds more moisture, you see.
Okay.
So in the West, that means more fuel for heavier flooding, but, and this is the critical part, that same moisture source from warmer oceans means when the cold air finally hits in the east, the potential for freezing rain is maximized. There's just more water available to freeze.
So we also have to touch on the specific geo-risks, say, in the Caucasus region.
Yeah, that area is flagged as a high-confidence alert zone. The combination of heavy snow, high winds, and temperature swings is making the snowpack incredibly unstable.
So avalanches.
Avalanches, mudslides, dangerous wind slab formation. It's a cascading hazard situation.
The big actionable takeaway for you then is this. It's an operational challenge of managing two totally different crises at once. You need flood and wind assets in the West.
While also deploying de-icing teams and blizzard response crews in the east, it's a logistical nightmare.
And we have one final thought for you to mull over.
Right. This eastern cold snap is intense, but it looks like it's temporary. The overall pattern is still, resistant to cold air. So you should be asking yourself, what happens when that mild air rushes back in after December 15th?
A rapid melt.
A very rapid melt. You should be watching for a significant secondary hazard. Flash flooding, mudslides, and dangerous ice jam floods as all that warmth moves over a deep frozen snowpack. Something to keep a very close eye on.